Cool. This is SIG Cluster Lifecycle on the 1st of August, 2017. And let's see what's on the agenda. There are 3 items on the agenda at the moment. I'm sure more will appear in a moment. But Justin has the first one with a list of blockers from the kubeadm adoption working group. Justin, are you here?
Is it just me? Okay.
Is anyone who was in that meeting here and willing to summarize?
I think the meeting's going to be right after this, though, isn't it? Am I wrong, or was it right before this?
We had one. We had one last week, and we had stuff. Let me pull up the minutes here and see if I can't jog my brain.
Yeah, I mean, I can summarize briefly. It was basically we sort of went around the room, and everybody sort of introduced themselves, talked about sort of how they were related to Kubernetes and kubeadm, and then we started collecting a list of blockers for kubeadm adoption in various sort of production or non-production deployment tools for Kubernetes. So the goal of the working group is to start standardizing on everyone using kubeadm as part of their deployment flow. And we are trying to sort of make sure kubeadm actually works for everyone's deployment flow by collecting a list of things that don't work today.
And redefining what kubeadm is.
Yes, right, yeah. So this sort of feeds into like what kubeadm has to be to satisfy that goal, right? And so that's the bigger agenda item from the meeting is we want to standardize on kubeadm. Therefore, it actually needs to meet the needs of the people who want to use it. It looks like Justin has reformatted the blockers list from the meeting notes last week into a nice format, so people should take a look at that. And if you weren't there and you have other things you need to add to the list, please do so.
And don't we have another meeting today after this as well?
Yes, so presumably Justin will be at that meeting, even though he's not here right now. Yes, there's another meeting today, and I think the plan was to try to do bi-weekly after that.
So starting today, we'll have next week off, and then the week after.
Exactly.
Yep. Maybe Justin join now. Is it SIG AWS? Yes. Cool.
Yes, Justin. So Justin, I just summarized what we did in the kubeadm breakout meeting last week. I don't know if you probably didn't hear it, but if there's anything you wanted to say, that'd be a good time.
I'm sure it was perfect. And yes, we're meeting again immediately after this.
Yeah.
So any early indications? Because, I mean, we have a list of priorities in terms of stuff that we were working on with kubeadm. I imagine that things like HA and upgrades and stuff like that is near the top of the list for a lot of this.
In terms of blockers, I'd say certainly HA is up there. The list that we put together a document with the things that came up last time. We've almost ran out of time last time with everyone's like blockers or like wish lists and blockers. But I don't think GK has yet annotated that with their own list, right? And I think there are some other cloud or some other installers we want to hear from. The list is definitely, the link should be listed from the list should be linked from the minutes, and it is interesting to look through, partially because it's sort of surprising because it is different from what we are, I guess, focusing on. So it is definitely worth perusing. But yes, HA is on there. Upgrade we didn't even mention. Resiliency, I think, was one that I think would help for kops and kubecorn interoperability or the ability to interface with it.
Well, that looks like a good start. It'd be great to see more, because it looks like kops and kubecorn and the CNCF cross-cloud stuff is the only one that's annotated there, right? But I assume there's others with opinions that.
Yeah, I mean, GK was represented, but I didn't have the notes to. I presume you could add them in, right?
Yeah, and Chris has a list of things also that we need to add in there too.
Yeah, so just to answer like the AJ thing, well, AJ works pretty good, I think, like with kubeadm clusters, but you have to set up your load balancer and copy files around. So, I mean, I wrote up the proposal to like how we could do it with init and join, and Justin had a counter proposal with including moving away from init and join for like AJ, real AJ with some cloud things, but that's a side topic. Anyway, init and join, but what we discussed in the Friday meeting some weeks ago was that when we're doing this, it might not be that secure or that production ready, or how we. I mean, it's different criteria. I mean, for this, we'd use the Kubernetes API to store certificates from when moving from one master to the other, and that's also the CA key, right? So for some users like kops, where we can do CloudFormation or Terraform or whatever, that will be preferable. And those things are already available today if you have that kind of infrastructure.
It seems to me like one of the good things that we could do here is actually identify sort of common paths of actually using kubeadm and be like, oh, if you have this level of support, then you can use kubeadm in this way, and make sure that we can actually sort of like pull that thread through. Because I think, there's a ton of overlap. There's different scenarios. There's different places where other tools fill in pieces. And I think we know that that's a tool chest and you can put that stuff together. But I think if we actually had a concrete sort of like set of examples of here's how you actually put the tools together, I think that'd be incredibly helpful. So some of this seems like more documentation and making sure that we dot all the I's and cross all the T's.
Yeah, I think I think documentation is a crucial part of like the kubeadm working group effort.
And that was mentioned
exactly
by a couple of people that were there.
There's also I also put on I raised it as an architecture issue, but because of like where do we want to store our secrets, but it actually raised we got some valid feedback from the BootCube folk, or at least from CoreOS people, which is the idea that basically you treat the CA key as a snowflake, but essentially then you don't persist the keys at all. So in other words, your API server, each API server has on disk a key which it generates. It is signed by the CA key, but they don't share the same key. And if that machine goes away or loses its disks for whatever reason, a new key would be generated, which I thought was actually a very clever idea. Thinking through it. But yeah,
having each API server be an intermediate makes sense.
Yeah. True. Yes. You're talking about for signing further certificates, or well, that would be the kube controller manager, right, or whatever runs the CSR approver. Yeah, that's a good point as well. Yeah.
Right. The API server should never need to sign anything.
That's true. Okay. So it's the controller manager that does the service account stuff, which requires signing, and the CRT approvals.
Yes.
Yeah. So, but as I told Justin when he talked about this, it's unfortunately much more complicated than that. Where we run two CAs, one for the real CA and also one for API aggregation. I mean, I know, Joe, we talked about this, implications from requirements from SIG API machinery about API aggregation, for example. That changes the way we set up our clusters. So that's one. We have one extra CA just for API aggregation and a client that we pass to the API server. And this, well, our CSR signer approver doesn't handle multiple CAs well. So
okay, so I'm gonna. If you won't say it, I will. I think it's insane that we actually require multiple CAs anyplace. That's a bug. And a place where that happens is like the API server calling into the kubelet, right? That's the wrong way for this to actually work.
And that too.
Yeah, I mean, what should happen there is the API server should call the kubelet, and then the kubelet should actually look at something in the certificate to actually validate who's calling, right?
Exactly.
On the certificate. versus just saying if it's signed by the CA, then it must be good, right? Because that, like, if we follow that pattern, then that means that every integration is going to require a new CA, and that's just going to become total crazy town as we move towards more and more components in the system.
Yeah, there is a legitimate use case for having a separate CA for etcd though, and keeping that in a different cert universe.
Right, but I think that's a matter of like you know, when the API server talks to etcd, which client certs does it use? And, you know, it's okay to say, like, it's up to you to figure out how to provision, provide, and specify those. If you don't, then it can sign those itself, right? I mean,
yes. Also for etcd quorum, etcd is talking to each other. Like, it's,
yeah.
I think it's reasonable to have that be a separate cert universe than inside of Kube itself. Yeah,
absolutely. But still, I mean, we have to have now 2 CAs inside of like cluster infra communication, which is pretty poor. So the problem, or like the thing that we have to upload secrets to the Kube API, like if we want to do kubeadm AJ with init and join this term or next term or whatever, we have to upload it and like store it somewhere to be able to download it then on master 2, because they are shared certificates between all API servers. But I mean, we're going to use the CSR approach as much as we can, and hopefully API aggregation will change in some way the assumptions that it now has. So yeah, but that's the end goal, I think, to use the CSR approve assigner everywhere.
So I'm a broken record here. I'm just going to say this for completeness. The Spiffy stuff is making progress. There's actually going to be a lot of stuff. There's a community day tomorrow for a bunch of folks involved in that, and so there's going to be a lot more stuff shared. And I'm hopeful that we'll get to the point where that's real enough that we can actually talk about it seriously. But I'm not going to try and distract things between now and then. Okay.
Cool. So anything else on that topic?
I have a question. Moving forward, as we continue to mature our needs, or as Joe put it earlier, our design to rewrite kubeadm, what would be like the best way for us to interface back in with the SIG and the kubeadm dev team? Like, should we just be fleshing out the GitHub issue log, or what do we think?
So in my mind, I think one of the most useful things here is I think the document around sort of what are the blockers and actually breaking that down by feature, I think that's useful. But I think in terms of making sure that like everything adds up to something that actually hits a mark, being sort of user story scenario driven around like the tool does this and then this and then this, and that actually shows us how all these features kind of fit together to the point where it'll now unblock a new scenario. And so I think in terms of interacting, I think that would be the most useful in terms of getting everybody on the same page of like, oh, I can see how all this stuff adds up and I can see how this works with a particular tool. And then, you know, and then finding commonalities or, you know, common scenarios around multiple tools about how they would use this would be awesome.
Okay.
And also, I'm not sure like a full rewrite is needed, but like I think it's more finding the right extension points, right?
Yeah, I was mostly kidding, but I just want to make sure if we are going to be spending time putting together feature requests, I want to at least make sure they're in a format that works well for everyone else.
Yeah.
Yeah.
And in terms of rewriting, I would view it as like, how can we actually sort of morph kubeadmin into a tool that actually is the toolbox that everybody wants it to be?
Exactly.
That's I think probably the PC way of talking about that.
Well, yes, as someone who hasn't heard about the thought of rewriting it, it would be great to see, like Joe says, I think that like user stories, like what would this achieve? Maybe just like a nice pithy proposal that that sort of outlines the motivation for it that we could all comment on.
Okay.
Thank you for doing this work. I'm really excited about the work of this working group. So thank you everyone for doing it.
As someone who reviews a massive swath of Lucas's PRs, the thing is a constant rewrite. So I mean, it is we I mean, to be honest, it's been cleaned up significantly. So I think, all joking aside, there's been a fair amount of thought and refactoring put into how the phases roll. So
Cool.
I have one. I missed the first 5 minutes where we talked about this rewrite thing, but anyway. But the tactically, one thing we could do is I was thinking is as we extract functionality, and we've talked about kops wanting to use kubeadm via library. If that library actually lived in kubeadm, the repo. So in other words, we extract out the shared functionality now. kubeadm and Kubernetes becomes a shim into it. Kops calls into the same one. Kubecorn calls into the same one. Everyone calls into the same one.
I'm supportive of actually sort of being library first on this stuff. I think that makes a ton of sense. If we do that, though, I think we got to be responsible not to break people. And I think that there's a certain amount of we got to have our crap together before we can actually go ahead and do that. And I think we've had, the interface to kubeadmin has been narrow enough around the command line that we've been able to sort of play fast and loose in some ways, yet still maintaining a high degree of fidelity in terms of user experience. I worry that if we lock it down to API and we have to sort of be API compatible, that's going to be a higher burden. Not saying it's not worth it. I think we just have to change our thinking around that.
I think it rolls up pretty nicely at CLI level. At Go level or interfaces. I think it's probably 70% done or something. 60, 70. I think it will fit into this cycle to get it to 100%. The phases that we want to have now, at least. And then we can really talk through them and have them stabilized beta, Go level, the Go level interface beta in, or whatever stable we choose in 1.9. That's kind of my goal, at least. CLI level is also improving pretty quickly. I hope to have something viable to use, where all extension points that kubeadm currently runs are available at CLI level, but still in alpha, under the alpha subcommand, and then we can evaluate that one as well and see if it meets the beta criteria and graduate it the next cycle. And the same kind of goes for the API, configuration API, but that's a later topic in the meeting notes today. So I think we're in good shape and it's moving forward.
Cool. Speaking of later topics in the meeting notes, shall we move on to the next topic? Which I think is from Chris. Hi, Chris.
So perfect natural segue from going from the kubeadm API to a sort of next layer up, the cluster infrastructure API. Robert had mentioned it last week. I sent out an email yesterday. I know some of us have had ramblings at conferences and other cocktail conversations about this thing. Some for, some against it. But I think we're all at the point where we're ready to make an earnest effort here to actually come up with a valid proposal and see if we can push something through or at least get a firm no. So I guess to start off, to explain what this is it's an attempt to define an infrastructure API object for Kubernetes. One of the interesting bits to keep in mind as I continue to explain this is if we are to move into sort of the middle layer, thinking of the 3 layers of Kubernetes as the underlying infrastructure, VMs, subnets, networking infrastructure, etc. The middle layer, which is the control plane and kubelet, so underlying application, and then the 3rd layer, which is the above application, which is userland, effectively. As we are defining layers 1 and possibly layers 2, we are going to be touching into kubeadmin level resources. So the kubeadm API we were just discussing very well could be a nested part of this larger API if we choose to go that route. So there might be some interesting relationships we need to abide to there. But again, yeah, it's this idea that we want to be able to represent infrastructure in one way as a community to help bring the community together and hopefully get most of the fragmented deployment tools speaking the same language, or at least attempting to speak the same language, so that we can begin to start representing infrastructure in a meaningful way as a community. Other important caveats, Justin has, and actually a little bit of this is myself as well, we have spent some time building out the kops API, which does this and is a great starting point. I hacked together one for cubic ORN. I know Google has one. I think there are a handful of other tools that do it. Terraform effectively has one in the Terraform config files with the Kubernetes provisioner. So there's a lot of different ways of representing infrastructure, and we're hoping to bring that together. So that's the rant. Anybody have any comments, questions?
Is the Terraform provisioner, is that for building Kubernetes cluster? Is that for actually configuring a cluster that you already have?
I actually am not super familiar with it, but it was my understanding that it was, you could use the Terraform provisioner with regular good old Terraform configuration and get a Kubernetes up and running from thin air.
We should confirm. Sorry. Okay, Lucas.
So yeah, I guess, I mean, kubeadm is layer 2 in this case, like from where we have the VM or machine to getting the control plane up and running. So what I'm going to talk about next is like the API for getting, from talking to kubeadm and saying, here is how to run my control plane, or here is how to set up Kubernetes. So do you mean that like API, the configuration group would be embedded inside of, like as a blob, or in which way would it integrate with like the underlying layer 1 with infrastructure?
Sure. So I think exactly how that relationship is going to work, if at all, is still up for proposal. We have a repo on my GitHub. There's a link in the agenda for today where I had submitted 2 proposals, and if you guys want to pull it up, or I can screen share, one of which there is a control plane resource nested within a larger object, and the control plane resource is a one-to-one map between kubeadm flags and just API directives. So that's one approach. And again, I think the whole intent here is for us to get all of our proposals out on paper where we can side by side them and do a diff on them and understand pros and cons to each, and then hopefully come up with some solution that works for everyone, or at least is making everybody not angry moving forward. Go ahead, Lucas.
So I think my question is, what does layer 1 need to know about what's going to happen above? Like, what does the infrastructure need to know about, like, what Kubernetes version we're going to use?
Sure. Well, and I think that's sort of the point of why we wanted to look at having this hybrid object that crosses from layer 1 to layer 2. Because in order to get a Kubernetes up and running, it goes both ways. Layer 1 has to know data about layer 2 and vice versa. So having it in one place and making it easily accessible is powerful.
I see. Thanks.
Yep.
I just say I think this idea is great. I'd love to see this happen. I think, you know, we for whatever reason chose not to do this in core, and I think the outcome was not that we then had one incubator project which succeeded, but now we have 10. And I think that is the worst. That is a worse situation than where we should be. And I think having a spec that we can agree on is, even if we have different implementations, is a good compromise. I think in terms of tactics, like I think we talked about this, Chris, where we basically merge everyone, like literally do the union of the GKE spec, the kops spec. Anyone else that wants to go in there can throw in their stuff, and then we go like, well, look, these 2 fields have the same name. It's easy to do a migration. Or have the same concept, different name. And we basically like identify and pare it down, and everyone can say like what value each field brings, and we can figure out what makes sense and what we actually want to support. And we'll figure out what we want to do from there. And there'll be some tough choices at the end. Like if kops has some weird feature that one person wanted, like, do we want to put that into the spec or not? And what extension do we have? But I think I like this idea, and I like I suspect what will happen is we will get agreement rapidly on the node set or the group of nodes. We will have a much harder time on anything master related.
Yeah, just to jump on the first part of what you were saying, I think that we decided not to do this before because we were trying to sort of define what core Kubernetes was and to really focus there. And there wasn't sort of this notion of let's also build the ecosystem, right? And I think now we are sort of trying to stabilize the core and build more of ecosystem around it. And this is in that latter category. And so it makes sense to build this and try to standardize so we don't, like you said, have 10 or 15 different ways to install Kubernetes. It would be great to at least say, here's sort of a standard way to do it. And people are always free to build their own installers, but if we can sort of get the community aligned around one way to do it, then I think that'd be a big win for us so we can focus.
Totally agree. And you see this happen with CNI, right? Community came together, developed a standard, they started adhering to it, and now nobody even thinks about running a network layer provisioning tool that doesn't speak CNI. So
what's the envision interface for this spec? Like CNI is really like, standard in, standard out. Is this like we all agree on one spec that represents all clouds?
I think that's the general idea. As far as implementation of the spec itself, I think we're leaning towards defining it in Go and using Kubernetes API machinery, which would hopefully in the future open the door to building in things like infrastructure operators and using kubectl API to actually manage infrastructure as well. But I think part of the whole proposal and design process here is we're sort of asking for help and ideas from people and what they think would be a successful implementation.
I mean, I feel like Terraform already does a really good job of this in terms of having, you have provider-specific plugins for different clouds, and then you have your definitions of what you want onto the cloud. I'm wondering, why create something new when we have something like Terraform, where we could just adopt that as the standard way to deploy?
In my experience, Terraform is like a declarative way of driving scripting, and it doesn't offer an abstraction over the various clouds. So, and I think what we want here is we want a concept of, for example, I want to run instances in my cluster. And I don't want to say, actually, I want to run an AWS auto scaling group with, these particular AWS dedicated tenancy things. I want to say a Kubernetes concept about what I want. I want instances, and then the auto scaler will interface with that. So it is, I think, a higher level of abstraction than Terraform gives us. But I mean, kops can output to Terraform now, and certainly it would be attractive for kops for some of the other clouds to use Terraform's implementation. So, if we decide that Terraform is the best implementation available to us and that it saves us time, we should consider using their code.
I know, shipping to customers who want to run on AWS, and this isn't any particular criticism, it's just sort of my insight, is that we spent, quarters just working on AWS integrations with customers who have very specific requirements around exactly how their IMAs are going to run, or how exactly how they're going to set up their profiles, exactly how they're going to set up their networking. So I worry with any abstraction of cloud that those abstractions break down incredibly quickly when they hit the real world, and particularly when they hit customers who are working who have experience and certifications in these different clouds.
I mean, it's certainly a concern. I think I've been surprised in kops as to how well it has gone so far, and we haven't yet really got real support for GCE. I mean, we don't have a lot of users using GCE yet, but the next dimension of that same argument is like, even if you could do it for AWS, can you also include GCE in the same abstraction? And it seems to be going okay so far, so I am optimistic. The other thing is, I think, we can lead to an extent. So a lot of those requirements are legacy requirements, and we can say with Kubernetes, like, those are nice and your requirements are valid in certain worlds, but in the Kubernetes world, here is another way to do it.
I think something that's also very, very important to point out here is we're defining the abstraction and we're intentionally not caring about the implementation. So if a user can cook up some wild and crazy Kubernetes in AWS that has all of these specific edge cases that they want to run, well, they can write their own controller and their own implementation and do that. But there's no reason they still can't speak the same abstracted representation of infrastructure.
I guess so.
Go, sorry.
Just to speak on the legacy side, those are our customers with those legacy requirements. So it's hard to say, for us to say no.
Well, I mean, I think it's not about saying no, it's about educating them and guiding them to tomorrow. And you have to accommodate them today and also lead them to a more productive future. And that is why you earn money.
Well, I mean, I think this is kind of the crux of the cluster API is, can we build an API that is both generic and also specific, right? It needs to be extensible enough that people who want to have very specific control over what their nodes look like in their cluster need to be able to get to that level of control. And that level of control is going to look different on different clouds. And we need to figure out a way to expose that. And if we can't get that right, then this is not going to succeed, right? And I think that is the hardest part of this problem.
So I would worry about conflating cluster Kubernetes configuration and cloud configuration. And I think there's a lot of room for cluster-wide configuration because we do things like installation time decisions. Like if you select a certain service cider, that plumbs through to kubelets, to DNS, to kubeproxy, to controller manager. Like it touches everything. And if you want to go back later and based on that install time decision, do something like during an upgrade or template in that value, you're kind of going to pick one of those and try and get a source of truth out of it, but it might not actually be correct. So I think there's a lot of room for like a cluster-wide configuration that we can all agree upon that are like those items, like what is your service cider and what is, your cloud provider and those kinds of things. And I think that we could find a good abstraction there, but trying to bring cloud providers into this and like how they abstract nodes and load balancers and routing rules, I feel like that's just going to be a never-ending problem.
But some of those things you mentioned are not install time. Like load balancers are already abstracted by Ingress, right? And storage is already abstracted by the storage interface. And the other thing we can do here is we can learn lessons from how they built those and the mistakes they made. And I was talking to Tim Hawken last week about how he might build a Kubernetes API to abstract away nodes, taking those lessons that they've learned, right? So I think we can punt on some of the things you mentioned because they are not our problem as part of provisioning. And B, we can try to learn lessons from what they did to try to make them work across clouds. And there are definitely things that they would have done differently if they'd known.
And I also, it's not like I'm entirely optimistic. Like I do share a lot of those concerns. And that is why I think that we are going to have great success on the nodes themselves and less immediate success on the control plane and the mechanics of the control plane. I feel like a lot of the control plane stuff is locked on component config, taking that sort of improving. There are other improvements that are going to happen. And then the actual configuration of a kubelet and then the instances that run nodes is comparatively simple. There are fewer decisions that have to be made because also you assume that like the infrastructure exists, right? In terms of your IAM roles, your network, all of those things then sort of more or less have to exist. You sort of target a group, right? And you might target a network, or you might target an IAM set of decisions that you've made separately. And that's where I think we'll make progress by eliminating some of those decisions. But we also give a lot of value to Kubernetes users because then, for example, the autoscaler will integrate with, our node policy thing. So,
So as a point of clarification, would this be something like you define a node pool in Kubernetes and that we write code that interfaces with the cloud providers, not necessarily that then makes that true? So no longer using like auto scaling groups in AWS, you're defining a node group in Kubernetes that launches and destroys nodes in the AWS API.
So if I understood this correctly, it's like more the node group or that kind of thing is more like persistent volume claims. And then we have that kind of storage class or integration with the cloud that's the thing. And then we get the actual like auto scaling group in AWS, and that's the persistent volume. At least that's what I thought.
I'd like to cite at least a lesson of history to be mindful of the exact use cases that we want to hit first. mean, all of the cloud providers before GKE and AWS were even around. There was all the folks like Eucalyptus and HP Cloud and all these other things trying to do this exact same thing. But they did it with it was a little bit lower of a level, right? But they all failed. And then everybody adopted Amazon's API.
I agree with Tim, yeah.
I want to echo Tim. I think staying scenario focused will really help here. In my opinion, I don't want to be a naysayer. I do think that this is a hard problem, finding the right mix between something that is generic and not lowest common denominator and useful. I mean, it's a very difficult problem. That doesn't mean we shouldn't try, but it also means that it's likely that we're not going to be able to hit everybody's itch, you know? And so I think it's okay to recognize that if we can get 80% of the use cases here, that's still a huge improvement. But we should recognize that there's always going to be folks that have a different philosophy or different needs that aren't going to fit into this model. I mean, you know, and we've seen that with kubeadm, you know, itself, right? A lot of people are like, that's great. And there's a lot of people who are like, okay, you know, not my thing. And that's okay, right? We don't have to have one true way here.
I'm also, I think Joe touched on this, but I'm also concerned on hiding the underlying capabilities of individual clouds. I don't think it would be useful to have to recompile and release a new version of our APIs in order to pick up recently released cloud API like new GPU support or something. I think we need to expose all the knobs and figure out how Terraform does a really good job of this. Figure out how we can pass through these options, or it won't be useful and it won't be extensible.
So to be clear, I mean, Terraform does a good job by not trying to actually create a single model in any way, shape, or form.
Yeah, sure.
It's fundamentally a lower level thing than I think what's being discussed here.
As a counterpoint to all this, we do have, if we don't do this, like we are going to end up with a situation where we have 10 again, right? Like GKE is doing this, kops is doing this, like I feel like KubeCorn is doing this. Like it's going to happen, right? So the question is, do we want one API? Do we want N APIs? And maybe we can't have one API, or maybe it doesn't work. But I actually really like, Lucas, your suggestion or your analogy of the storage class as a sort of big extension mechanism where we sort of manage to define things externally without polluting the main object. The analogy I would use is actually ingress, where we have a spec and we have very different controllers. And we've seen some of the flaws of that approach, but it does seem to work or it seems to be the model that I think we would want to follow. We have some easy, the use case that I'm most excited about is it turns the act of installing into setting up your control plane, and someone sets up the first node set.
Isn't storage class just a map from string to string? That's the entirety of the body.
Okay.
It has it has very, like, almost no structure.
We can probably do a little better, but I like the idea of pulling in, having sort of those sort of external mechanisms that, I don't know. I think we've all decided that annotations don't really work, but I don't think we yet have figured out what does work.
Yeah, absolutely.
I think there's two things to consider in this discussion too. One is that with the cloud provider breakout and getting that code separated out of the core, that's going to give us some flexibility about implementation details. And I think one of the things that maybe we could look at is, what are the primitives that we can count on as far as installation geometry of any particular setup, and start there and work our way down. So the deeper you get outside the primitives, the more you're going to be dealing with implementation details, and the more we can abstract that out to cloud providers. So for example, if there's, in Amazon, you have the notion of a region and a zone, whereas in Azure, you just have a region. So ergo, you have region as a primitive and zone is an abstraction of that primitive. There's going to be things like that we can identify and move forward on. So maybe not eat the whole elephant once, but try and carve out those top level primitives that pretty much apply to any cloud, and then break it out from there. So we're not trying to do it all at once.
I think one of the useful things is I am excited to start playing with some of the abstractions that the Lutzi guys have been talking about, where if if we do model first and then node comes afterwards, then we can start manipulating those models in a generic way. So specifically, it's the idea you create the node object in Kubernetes, and then the node VM gets created after that instead of reversing it. As we start doing that, now we can start thinking about writing controllers on top of that, and actually thinking about. So I think the scenario for me that actually starts to really sing is sort of, how do we actually start to get to a generic view of cluster auto scaling, or sort of cluster sort of node pools that are a generic concept? Because right now all of that stuff is very much in the sort of install domain.
Well, I think it's important that we start to introduce this idea of the nodes, which is a set of sets, right? And then the control plane being completely separate, and a valid definition of a cluster being either or both. So control plane, nodes, either or all of the above. And that changing over time is pretty important. But I agree. I think when you said the phrase "sing," it really resonated with me. Defining nodes first and having that be declarative is a big win for us, and makes sense.
Cool. Sounds like a really good project.
So we have 15 minutes left. Jacob had mentioned to me, Chris, that we were thinking about having another sort of breakout meeting for this specific topic. Do we want to discuss that quickly and see who would be interested and what times they might be available?
Yes, please.
And then I think we do want to sort of keep the conversation going in this meeting also, not just completely take it away, because not everyone's going to be able to make another meeting. But in terms of diving into details, I also don't want this meeting to just turn into talking about the cluster API. Like, we need to have this meeting sort of roll up all the different sort of sub-projects that are going on, and maybe spend 10 minutes of each meeting sort of discussing each of them.
Totally agree.
So
I would say we take the approach that Justin and I think Lucas as well set forth with the kubeadm adoption group, and just do the Google Doc, and we can vote in there.
Cool. Do you want to send one of those out?
Sure.
Thank you.
Cool. So that sounds good. I think the next item on the agenda is from Lucas on the kubeadm v1 beta 1 API.
So yeah, we talked about this a little. Right now, our API, like our configuration API, is alpha, and it has been alpha for a year. I'd really much like to get some feedback on, like, this is an RFC, a Google Doc, and pull request attached with like just the basic types of what it could look like. And it's basically, at some point we have to promise something about the configuration file. Right now we document everywhere that, well, if you use this, it's experimental. Do not use this, kind of. But a lot of users have to use it because they want to specify something in the like API server arguments, or they have to do something a little bit custom, or they want to enable the in-tree cloud provider integrations or things like that. So I think it, as part of pushing kubeadm to GA eventually, I think it's time to at least discuss this abstraction of, again, abstraction about how do we set up the control plane. And I mean, this kind of goes hand in hand with what we discuss in the other layer 1 infra meetings as well, cluster API things. But I think it should be as little. I mean, kubeadm should do as little as possible, kind of. The minimum amount of effort that is useful for a lot of users, but still not doing everything or like handling all corner cases. And I think what I have there is kind of in between design. So, I mean, this is a stretch goal for 1.8, I guess. It would help a lot with upgrading, because right now from 1.7.4, kubeadm is going to upload the config file used, or like if you do kubeadm init with pod network subnet or something, you want to use flannel, then it will, I mean, internally it will use a config like this API object and upload it to a config map in the cluster. And then when we upgrade, it's going to check out this config map, parse the API types, and like based on that, regenerate the manifests. And we'll then notice that, oh, I should use this this argument to the controller manager so that flannel still works after the upgrade. That's one example. And yeah, if while our API group is alpha, we don't know if future versions will support like reading our old configuration. So I think this would help a lot if we could promise something actually about our API group.
So the reason to have it be alpha isn't that we won't know if they can't read future versions. It gives us an out if we want to change the structure, because we aren't making a promise to other people that it will stay consistent going forward. So the question really comes down to, are we ready to sort of lock in what we've got in the API and promise backwards compatibility?
I think there's still work to be done to get it there. I've looked at it recently, and it's still very unstructured, and there are unreferenced types that are not top-level types. It needs to be, there's some significant cleanup that needs to go into it, and I think a bit of thought on how we want to structure it still.
So yeah, I totally agree that the current state is really not optimal, but I mean, that's why I have the proposal. Did you take a look? Did you have time to look at that, or?
Is this the really old one in the kubeadm repo, or is this a new one?
New one, linked now in the meeting notes.
Thanks.
I'm loath to rush it, other than to like we can have a cycle where we explicitly try to support, but still hold the ability for us to say that the API could change. I mean, just like Robert was saying a second ago, it's just a guarantee that we won't break compatibility across releases. And I think we will still strive our best, but then it gives us a time to churn it out across the 1.8 cycle, because this is the first time we're going to store that object inside of the cluster itself.
We could also create a V1 Alpha 2 and work on conversions as we restructure V1 Alpha 2. That's another option. I think a lot of the changes could be compatible, that we've made so far could be compatible across API versions.
Yes.
I think I commented that kops isn't in a position to adopt this, or it doesn't make sense for kops to adopt this. I think that there's it's not clear to me what we're trying to model here, whether we're trying to model an abstract model or the concrete, like these are the commands. So for example, like there's a map of arguments, right? But what do those arguments mean? What should happen as those arguments change underneath us? There's a map of host path volumes, or a list of host path volumes, right? What does that do? There's a path to a key. Is kubeadm going to enforce that the key exists? Like, which key am I using? What if we invent a new spiffy crypto system that doesn't use keys, right? You know, it's something like all those sort of, what are the guarantees we're making? What is this model saying is sort of what I don't really understand. And it feels very much like a Terraform abstraction, right? Where it's like a declarative thing of saying like what we want to put on disk. The problem with that is as the thing we're manipulating changes, or like, you know, for Terraform, it's like as you switch to a different cloud, we effectively end up having to rewrite the Terraform manifest in the same way we'll have to rewrite, in our case, this model, I think, particularly as component config comes online and flags don't even mean anything anymore. None of the flags are going to be supported in the next version of Kubernetes, or whichever version that is, right? The future version of Kubernetes that doesn't support any flags, like, what do we do? So that's sort of where I'm like, this doesn't really make sense for kops. So kops has from a philosophical point of view, it's just as bad, right? It is we embed what we think component config is going to look like, and we currently render the flags from that. And the idea is that when component config comes along, we will render it into component config. So it's that sort of, and eventually we'll just get rid of it and just say, just use component config, right? So that is what we're sort of saying is our roadmap for what we are representing. We're representing the actual intent, not the flags themselves. And as Kubernetes evolves, it will move into Kubernetes.
Yeah, so regarding the flags there, It's a string map, yeah. And ideally, I mean, if I could, I'd just use component config. I mean, but that's right now. I think it's going to be removed, right? Like the what exists right now in core.
It's just going to be moved.
Oh yeah, moved. Yeah, to something again, something beta level, or I mean, the current component config API group is alpha, right? So yeah, so I'd happily use that if it existed, but my thought is like, this is the interface like for how to bring up the cluster, right? And what options are needed. But still, I mean, it's, well, definitely a hard problem. We could, yeah, I don't know.
Yeah, the other thing is that the component config is actually, for kops at least, we actually have a model on top of that. So we actually, users don't typically even set the options which set the flags. They set options which set the options which set the flags, right? So it's like a whole nother, so we have like a networking top level object. And if you say networking weave, that triggers CNI, it triggers, I don't remember all the other things it triggers, but you know, like disables allocate pod siders on the kube controller manager. So we encourage, users can drill down if they need to, but that's the model which we feel we can support, some sort of very abstract, like I want to use weave from my network type model, not these are my flags.
Yeah, this is low level. Yeah, this is pretty low level, and you should have something above it, right? If it's kops or if it's like tectonic or G-key or whatever, it's definitely meant to use. Not for more like admins or your higher level cop solution here or whatever. But this is, I mean, I'd love to spec out a beta API config to kubeadm. Like how can we tell kubeadm to do something to spin up the cluster, and then have some guarantees around that. And yeah, I'm like the way I did it now was to use conversions. So we'd still support the all for one, V1 all for one API like for a cycle or something like that, and it could be easily converted to the beta version. So the current version is alpha, but we're treating it as beta, like level of you are not stuck if you're using the alpha version, but we actually promise something from getting the beta version done.
So I'm not that close to this, but maybe that helps. My question is just if we're saying that this will get easier when we have component config, should we not just wait until we have component config before we try and make this change? Or will it not actually help that much?
It's an additive, addition. We could just add component config when it comes, right? It won't change that much. I mean, then we'd just say that you can't set both the string map and component config. You have to choose one, and then we'll just get rid of the string map when we can.
Okay.
My problem is we don't have a holistic view of how we want to organize it, and that there's a couple options, and I don't think we've discussed this thoroughly. Do we want to organize it by phases? Do we want to organize it by components? Where there's no obvious place to put new configuration, and right now new configuration is going in the top level object, which seems like it's a fast path to implement all these new features that we want to expose on the command line, but it's not going to lead to a good API group, and I'm just worried about rushing that before we thought it through.
Interesting. Okay, with 2 minutes left in the meeting, I'm going to, sorry, Lucas, skip over your other item and just ask is Jace on the line? I don't know if I pronounced that right, sorry.
Yeah, I'm here for sure. Yeah, so feature freezes today. Make sure that if you haven't put your features in, please do that. If you need help looking what a feature is or isn't, just look at the features repo README has that definition. And there was some reports of some test flakiness in the kops test. So if anybody felt magnanimous and wanted to look at those, that would be great.
Cool, good shout.
Justin, you're muted.
I was just saying, where can I find the report? Sorry.
Testgrid.
Okay, that's great.
I'm going to make a short URL for that sucker.
So just looking at that list now, I see we have upgrades with self-hosting in kubeadmin. Do we think we're on track for that feature?
Absolutely.
Awesome. Are there going to be any other features that we land that are not on this list?
Well, I don't know which list you're...
I'm looking at the list that was linked to from the comment in the... it's linked to with they are in. And it's a list of the issues in the features repo filtered by label SIG cluster lifecycle.
Yes, out of 3 cloud providers will hopefully get to beta. It's not touching us that much, but well, since we have no SIG cloud, it's SIG cluster lifecycle labeled. At least there's some work going on there. Bootstrap tokens to beta is in good shape. Well, progressing well. Upgrades with self-hosting, yes. And what we talked about some minutes ago was extensible configuration, invocation of kubeadm, and ability to create dynamic HA clusters with kubeadm. We have the kind of work in progress design doc there, but not implementation.
There were also some that were mistagged as SIG AWS, which were for kops, so I've tagged them into SIG cluster lifecycle as well. So
Thank you so much. That helps a ton.
So
great. Well, we're on the hour, so thank you, everyone. This was a good meeting. Yeah, that list of features is looking pretty good. So great stuff. Thanks, everyone. See you next time.